All right, let's have a look at example 10. Okay, so example 10 is kind of like a very common application question that you guys would see in the exam or read something like that. It will be as long as this one and it will be as easy as this one when you actually know how to do it. From a square piece of metal of side length 2 meters, so if I see that, I instantly mark into the shape. Side length, square piece of metal side length 2 meter, 4 squares are removed. So what they're saying is the 2 meter goes from end to end like this. Alright, so this is your 2 meter. Alright, because they said that 4 squares are removed, so they remove like the little square here. I'm just gonna draw that little square in. This is the square that has been removed in order to make the shape here. And then the metal is folded along the dashed line to form an open box with height x. Okay, how would I put in this height x into the shape here?
Like the little here and right.
Yes, that is correct. Is that tiny bit there? That is x. Regardless of where you draw it, it will be the same. Now, new type of question. You guys haven't seen a show that question before, right? Have you? Yeah. So for show that questions, you normally have to start on one side and then you have to like somehow show it to the other side. Show that is equals to the other side. Okay. So for question A, and normally in the exam when you see show that question, don't do it. Don't do that one first. Do everything else first. I'll show you guys how it works. So for this one, right, they say show that the volume is given by this, which means they already gave you guys the volume equation. So why bother finding it? It would be like 2 marks, but it would be a lot more difficult than just a normal 2 marks. So what's the point? Skip that. Use the result to find B. So let's go for B first. Find the value of x that gives the box the maximum volume and show that the volume is the maximum for this value. So there are two parts. Find x and then show that the volume is the maximum. Now, the part where you're supposed to show that it's a maximum, what do you guys think we would use? What technique will we use to show that it's actually a maximum?
Like the stationary point?
Yes, the stationary point table. That is correct. Okay, so for question B, once again, I'll have a draft side here. So find x is just the basic stuff, right? And maximum volume, it just means you derive, set that equals to v dash equals to 0, find x, right? And then find, we're just finding the x value, so that's it, right? And then the show that it is maximum, show maximum is going to be done via the table. Alright, that table x and then v dash and then the shape thing. Okay, so let's just slowly work through that. First, we will need to derive v dash equals to 12x squared minus 16x plus 4. Set that equals to 0, so 0 equals to 12x squared minus 16x plus 4. Divide both sides by 4. That will be 0 equals to 3x squared minus 4x plus 1. Okay, let's try the ACB table on this side. ACB, AC equals to 3 and add up to negative 4. Yep, we can factorize it. It's negative 1 and negative 3. Yeah? So factors of 3 is 1 and 3, but you have to add up to negative 4. So that'll be negative 1 and negative 3.
Yeah. So then you do your little bracket.
Not yet.
Do that.
Why can't we do it in this question?
Because you have to solve for like.
And why? What type of equation is this?
A quadratic.
What type of quadratics? Specifically, what type of quadratics? When can we just get to the bracket straight away?
And I have to do the funky thing.
Yeah, you have to split the middle because this is a non-monic.
That thing.
Yes, non-monic, so the x squared is not just 1, there are 3x squared. Alright? If it's non-monic quadratics, you have to split the middle term. split the 4x term. Alright, so now we've got the two values, -1, -3. In your actual paper, it's got to just split it. So minus 3x minus 1x plus 1. I like to write the 1 so that it helps me take out the common. Yeah, when you take out common factor 1, it will be a bit more obvious. And then minus 1, x minus 1. Now it's just working through the x. Okay, so we've got the two values for x, 1/3 or 1. Okay, so this is an example where we don't know which value gives the maximum volume.
So you have to do that.
So you have to use a table. Yeah, the table will tell you which one is the maximum because
So are these the stationary points?
yes, these are stationary points because we set the derivative, right? We got a derivative, we set it equals to 0.
Yeah.
So when you solve for the variable, it's the variable of it's the coordinate of the stationary point. Yes.
Okay.
Okay. Now we do the table. Yeah, so it's going to be your same thing, x, v dash, and then the shape. Alright, we've got 1/3, we've got 1, and at these 2 points it will be v dash is 0 and the shape is horizontal. Value before 1/3 would just be 0, value after that. Now, I would actually look at the v dash and see if I can factorize it. Oh, not really. Okay, that means I will choose a value that makes my life a little bit easier. And you know which value I'm going actually.
Would you just do like 1/2? Would you just do like 1/2 for the middle? Or would you like to?
You can. 1/2 is a good choice. 1/2 is a good choice. So 1/2 will be, you can choose 1/2 as a value here. Alright, because 1/3 is like 0.3, so you can choose 0.5. Yeah, 1/2 is a good choice. And after 1, yeah, I think the easiest one is just going to be 2.
Yeah.
Okay, so sub 0 into v dash, and once again, I'm just going to write a v dash here just for clarity. 12x squared minus 16x plus 4. And what did I say before you sub values in? You take out common factors. Okay, so you see that if you take out a 4, it will make the calculations a lot easier. So let's see, v dash of 0 would be 4 times 0, 0, 1 is 4 times 1, which is 4. Yeah, and then v dash of 1/2, alright, let's see, that will be 4 times, and then inside here it will be 1/2 squared is 1/4. Alright, so that will be 3/4. Make sense?
Okay.
Yeah, Sarah? Yeah? And then minus 4 times 1/2 is just minus 4/2 plus 1.
Yeah.
Alright, so that'll be 4. Anyway, we need to work with a bit of fractions here, but 4/2 is just 2. So that's minus 2 plus 1, and then 3/4. Minus 2 plus 1 is minus 1, so 3/4 minus 1 is what?
Negative 3 over... No. Negative 1/4.
Negative 1/4, yes, and it's 4 times negative 1/4, which is minus 1. Right, because the 4 here just cancels at the bottom. So that would be minus 1. I'll just put these values slowly in. 4 positive, minus 1 negative. And when you sub 2, v dash of 2 would be 4 times, and then that'll be 2 squared, which is 4, times 3 is 12, minus 8 plus 1. So that would be 4 plus 1, which is 5, times 4 is 20. It doesn't really matter what the value it is, because you need to know it's positive.
And then you just find whichever one's the maximum.
Yeah, so which one is the maximum?
1/3.
Yeah. So, therefore, max at x equals to 1/3. And then we need to find the volume at 1/3. When x equals to 1/3 would be...
Use the original equation?
Yes, it would be an original equation. That would be 4 times 1/3 cubed is 1/27.
What's the outgoing?
Actually, okay. Again, I'll use my I'll use my recommendation, my own recommendation, which is to factorize it. So let's write it first. 4 times 3x cubed plus, minus 8x squared plus 4x. Okay, I'll follow my own recommendation, factorize it first, and you see the answer. It will be a little bit easier. Take out 4x, then you got x squared minus 2x plus 1. Okay, now I sub in 1 over 3. Alright, so that'll be 4 times 1 over 3 is just 4 over 3. Alright, and then in the brackets, 1 over 3 squared is 1 over 9. And minus 2 times 1 over 3 is minus 2 over 3 plus 1. Now it's got to work out the brackets first. So that'll be 1 over 9, make everything over 9. So that'll be times 3, so that's minus 6 over 9 plus 9 over 9. Okay, so that'll be 10. 1 plus 9 is 10, minus 6 is 4. That'll be 4 over 9, and
so
everything is...
negative 5, 9 plus... Yes.
Yeah, so it'll be 16 over 27. So yeah, so the maximum volume you can get is 16 over 27.
Meters.
Yeah, so for this question, I will, hang on, let me just put the draft here. And then at this point, you need to write the answer. Therefore, minimum or maximum volume, yeah. Therefore, max volume equals to 16 over 27 meters cubed. Meters, right?
Yeah.
Ah, meters cubed. Okay?
We do C.
Yes, now we'll do C first. At the very end, I'll show you guys how to tackle question like A, where it's like show that something. But for now, we'll do everything else, because everything else is normally easier to get marks for. Sketch the graph of V against X for a suitable domain. Sketch the graph, that means we have got to find... Sketch means find two things. What are they?
Your x-intercept and your y-intercept.
Yep. So in combination, it's called axis-intercepts. X and y-axis intercepts.
Stationary.
Yes, and then your stationary points. Yes, we already got the x value. We don't have the y value. We have the y value for one of them, for 1/3, but we don't have the value for 1.
Yeah.
Alright, so we need to find v of 1 first. So v of 1, again, sub into the factorized equation here. That would be 4, and then 1 minus 2 plus 1, which is 0. Oh, handy. The volume will be 0. So, okay, so those are the two stationary points, and now we need to solve for the intercepts. What's the y-intercept?
When x equals 0.
Mm-hmm.
So...
It'll also be 0.
0,
Yeah. Okay, so we solve y-intercept. V of 0 will just be 0. And then x-intercept, sub 0 into the equation. I'll use the factorized v again. So you see, if you do the factorized version of the equation, most of the time you will end up using that later. So you only have to factorize once. It's a very good habit in math methods. It's just factorize your equation. So 0 equals to 4x, x squared minus 2x plus 1. So then x equals to 0, or x squared minus 2x plus 1 equals to 0. What are the answers for the quadratics here? Can you guys see it?
Wait, give me a sec. I think it is negative 1 and negative 1. Right?
It is negative 1 and negative 1, correct? Yeah, it's just the ACB table again. Yeah, so AC1 be negative 2, so this one will be negative 1 times negative 1. And this is monoquadratic, it's just 1x squared, so that'll be x minus 1 times x minus 1 equals to 0, which means it's just x equals to 1, only one answer. So this equation only has two x-intercepts. The first one's at 0, the second one is at 1. And what happens at 1? It's also a turning point, stationary point. Okay, let's put all the points in. Yes, you got to draw it now. What are the x values? 0, 1, 1/3, which means the scale, very important. And also you need to think about what the y values are. So let's see what the y values are. 16 over 27 and then positive, right? And then 0. Yeah. Okay, so then we've got 16 over 27. I'm just going to put that value in here, and then 0 is like here. Okay, and then we've got 0 and 1, and then 1/3 is like a third of the way through. So yeah, it's very important to get the right scale, otherwise your graph's not going to be visible. Yes, it will look ugly. Alright, put the points in, different colored pen, 0, 0, and that's also, no, that's the x-intercept, yep, and the y-intercept as well. And then stationary point.
The other one is boom.
Yeah, 1, 0 and 1/3, 16 over 27 and 1, 0. Alright, so the top one will be, yeah, and then it will go to this one. It looks something like this.
That one looks really good, quite.
Which one?
Look at my curve that I did. Freehand.
Freehand, very good, but you cannot get it past 0 and 1.
Oh, can I not?
Yeah, technically you can't draw it past, you can't draw it past 0 because the height can't be 0.
Yeah.
And side length
It can't be.
2, yeah, side length 2, it can't be 1, it can't be like past 1 either.
Yeah.
Because,
It's just
yeah, it's like, I think it's only 2.
Could have looked.
Yeah, it's good. That's right. Yeah. So put the points in. 1/3, 16 over 27, just to make sure the examiner sees that. Yes, I know you're looking for the stationary point, so I'm giving you that. Give me the mark. Okay. So yeah, so that's question C, and then find the values of. Okay, question D. Find the values for which V equals 0.5. So how do we do this?
Sub 0.5 into the original equation.
That is correct. 0.5, which is 1 over 2, equals to the V equation. Now,
X squared minus 2x plus 1. Right? Are we doing like the factorized one?
hang on. This one you need to use the calculator. You can't solve it by hand. So this question is like a mixture.
Are you
It's,
sure?
yeah.
Can we use our big brains?
It's no, you can't, because you can't find a whole number to solve it. You guys know how to solve cubic equations? The factor theorem from unit 1. When you solve a value in, if the equation becomes 0, then x minus that value is the factor, and then you long division cubic. No, doesn't ring a bell. We'll get to one of these questions in unit 3 for sure. But for now, let's hope that it's not going to come out. So yeah, so we'll just submit into this one, and then most likely you need to use a calculator to work through this question. Yeah, the answers are decimal numbers. It's strange. I don't really like the textbook in that sense. They don't tell you which one is calculator, which one is not calculator. So yeah, it's a bit confusing.
Is that external exam on, is it just unit 3 and 4, or is it?
3 and 4. Only 3 and 4.
Okay.
Yeah. So note that whatever you guys are learning now is contributing towards unit 3.
Yeah.
But there are certain things in unit 2 that you guys want to be tested again. For example, the first principal derivative. Remember that?
Yeah.
The lim thing. Yeah. Lim and then fx plus h minus fx over h. That thing. We won't be tested again after unit 2. Okay. Anyway, so using GC. You guys know how to use GC to find this one?
So you just like substitute in and then comma x, like.
Yes, so either you use NSOLVE. However, this is a polynomial of degree 3. How many solutions do you think there will be?
3.
3 solutions, right? If there are potentially 3 solutions, the NSOLVE I think only gives you 1 solution.
You can like, can't you do something and then you say like it's a polynomial and then you put like the degree in? I feel like there's a thing.
Not sure if you can do that.
I feel like it's like I've done in class.
Oh, okay. I haven't tried that before. So what I normally do for this case is just, make everything. So move everything to one side. Move to one side, right? So for example, in this case, I'll just go 0 equals to 4x cubed minus 8x squared plus 4x minus a half. So that's moving everything to one side, and then graph it. So once I've graphed it, I can find the root or find the zeros. That make sense? It's basically, so when you graph this one, you get a cubic equation, right? It's like, looks something like this. And then you're solving for when x equals to 0. So it's just finding what that point and that point and that point is. Those 3 points will be your answer.
0
So,
5 or 0?
0. Because I moved the half over. If you didn't move it over, then you would have to draw an extra line.
Okay.
Right? So y equals to 0.5 and find the intersection. So that's why I move everything to one side. To make it easier, equals to 0, and then you graph it and then find zeros, which is like the basic function in the calculator. So, do you have your graphics calculator with you? No? Sarah? No? Well, go back, try it at home then. So, but yeah, it's just essentially graphing it and find the zeros. Okay? If you guys, okay, just bring your calculator next week. Alright, so next week we'll try more calculator type questions, and I think we're in that area now. So finally, we can go back to question A. Right? Show that, so question A is, show that the volume is given by that thing. So let's look back at this one here. Let's say in the exam you guys have extra time, right? And we're okay, I'm gonna try to score 100 out of 100. Right, Charlie?
Yeah.
Yeah? And then you need to do every single question, aka you have to do question A as well. So looking at this one, you need to show that the volume, which means you have to start on one side. So the left hand side is just the V, and then the right hand side is this thing. Okay? Any show that question, you start on the left hand side. So the structure of a show that question looks something like this. Let me put some here. So for show that questions, alright, it will always be left hand side equals to something, and then you work through it. You have like a million lines in the middle, and then equals to whatever it is, and then you say, oh, this is the right hand side, bracket shown. This is the structure of the show that equation. Okay, so left hand side equals to volume, right? And how do we calculate volume? Volume is, in this case,
minus 8x squared plus 4.
sorry?
Like the equation, that's the volume?
No. We're not looking at this equation yet. We can't use this equation. We have to look at this to calculate the volume from the shape. So if you were to fold it up, it sort of looks something like this, right? Yeah, and the height is going to be x.
Yes.
Right, we just need to have the length and the width, and actually in this case it's going to be a square base.
Length
so what's that?
Height times width.
Yes, that's right. And what's in this case the length and width is the same, right? Because these two is just the same, right? Because this is a square. Side length 2, so both lengths are 2.
It does not look like a square.
It's supposed to be a square.
Yeah. But is the base a square?
It will be a square because when you subtract x on both sides, so that'll be x, that'll be x.
Uneven?
It may look a bit uneven, but technically it should be a square because you're removing x on each of these, right? So it's xx, which means if it's 2 here, then I'm giving you guys the answer, but this will be 2 minus 2x.
2 minus, oh yeah, 2x. Okay.
Does that make sense?
Yeah.
And this side is the same. It's going to be 2 minus 2x on this one, 2 minus 2x on this one, and then 2 minus 2x on this one as well.
So we...
So what's the volume?
Yeah.
So then...
It's like 2 minus 2x times 2 minus 2x times x.
Yes, correct. So using that, right, I'll put it down here. So that would be 2 minus 2x, everything squared, times x. Right?
So
Because it's a square base.
2 minus 2x first, and then just multiply that whole thing by x after.
Yes, that's right. So expand that, that would be 4 minus 2 times 2 times 2, which is 8x, and then plus 4x squared. And then everything is multiplied by x. Alright, times x. Then you times x in, that will be 4x minus 8x squared plus 4x cubed. Does it look like the right hand side yet? Not really. So we need to rearrange it to make it look like the right hand side. 4x cubed minus 8x squared plus 4x. Now does it look like the right hand side of the equation that we're trying to prove?
Yeah.
Yes, and then you write equals to right hand side brackets shown. So these show that questions, if you get to do them, they're quite fun to do. It's just a bunch of algebraic manipulation. Alright, it just show from one side equals to the other side. But the structure is very important. See, you start from the left hand side, you write it equals to whatever the left hand side is, and then using a different way. You can't look at the answer, right? The answer is only there to help guide you towards the answer. But you need to use a different method. In this case, it's using that little, that little shape there. Right, where this one would be x, and then this one would be 2 minus 2x. Okay, in order to find the volume. So using that, expanding everything, then you get equals to right hand side shown. It's almost always going to look like this. Right, almost always has to start with left hand side, and then equal, like a whole chain of equal, and then finally you get equals to the right hand side shown. So it is the same structure here. Alright. Okay, so that's the structure of a showed up question. Make sense? Okay, now your turn. Try question 4.
Are they gonna teach left hand side and right hand side?
If the teacher is experienced enough, they will teach you. But otherwise, I don't know how else they will teach this one. But basically, this one is a university level working, so it must be correct. Trust me, this is mathematically universally accepted. So anyone in the QCAA marking your external will know about this. Almost everyone in the QCAA will know about this because they're very advanced math teachers. So they would obviously know about this one. High school teachers, can't guarantee. And just note that the LHS, left hand side, right hand side, you can use those. 100% you can use those. If your teacher somehow complains that, oh, you can't use that, bring it to the head of math. The head of math will vouch for you. I can vouch for all head of math in all schools. They will know about this format. Maybe a trainee teacher may not know. I don't know. And most of the time, this format makes sense as well.
I think like my teacher kind of forgets because a lot of the class, like a good part of the class, does specialists and they've learned it in specialists. Maybe she forgets, but like I feel like something she doesn't go over too much.
Oh, so she would show it, but not like explain.
Yeah, and it's like just a small part.
Ah, and it doesn't make sense.
Yeah.
Yeah. So when that happens, so when she goes over it, is it like a OneNote file? Do you have it or yeah? So if you don't understand anything, you can just send it to me. Yeah. If your teacher is too busy, most of the time they're taking care of, I don't know, 10, 20 kids. So just send it over to me. I'll give you that little bit of explanation and it will make sense again. And yes, you're correct. That left hand side, right hand side thing is a specialist thing. So if your teacher teaches specialist, she will know about the whole left hand side to right hand side kind of proof. Because in specialist, you do that so often.
Wait, is it considered a proof? Is it considered a proof?
A proof? Yes, it's mathematically correct. So no, there's no other convenient way of doing that kind of question. So put it this way, the math methods in Queensland, they may not explicitly show that concept, but like in Victoria and maybe in capital territories, they will teach these concepts because the questions down there are way harder. I think Queensland is getting there though. So.
When I find like my 3 stationary points, do I substitute them into like the factorized one, or do I substitute it into like the original derivative, like that hasn't been like factorized?
The answer to that depends on what are you trying to find.
Like the maximum point.
Mm-hmm.
Using like the table.
If you are using the table, see the second row. The second row is
So then, but would I substitute into just like the original derivative or my derivative once I factorized it?
The factorized one.
So like one of my own like brackets and stuff.
Yes, because the answer will be the same, but the factorized one is easier to work with.
Okay.
In this question, I'm just going to work through it in like the exact order. So A first, then B. Because you should know how to do A now. It's very similar to the other one.
I don't know if I've done this right.
We'll see.
Is this right? But shouldn't it be negative? My one for
X is not 0.
is it not?
No, because it's not. There's no X outside. It's only 12. So we just divide by 12, which is gone. There's no X outside. You only have X equals to 0 when you have X and then times the whole thing. Alright, and that X can be 0. But in this case, there's only 2 answers. It's a quadratic. There's only 2 answers. So if you notice, if you use the fully factorized version of V dash, it's even easier to work at. Alright, because the final step is just doing a bunch of multiplication. Okay, so here's the full answer A and B.
I'm giving it away for you.
Just work on it on your own, and then when you're done, you can have a look. Oh. Sorry, Black, I forgot to turn on the recording for the absolute maximum and minimum, so you might have to ask Charlie to explain the absolute maximum and minimum. But in short, just find the coordinates of the stationary point and then the end point. Because you could either have a scenario where the absolute maximum is higher than the local maximum and then the absolute minimum is lower than the local minimum. But you can also have the scenario where the where the absolute minimum is also the local minimum if the graph doesn't actually dip below the local minimum. So yeah, so to solve this one, just find coordinates of stationary point, coordinates of the end point, and then when you lay them out in like a vertical line, you can see what's the highest point and what's the lowest point of the graph. And then try question 9. Okay, I'm slowly working through this one. Alright, Charlie, did you get 2 and negative 30?
Yeah.
Sarah? Yeah? Okay, alright. We actually might have time for a short question. Let me see. Alright, question 11.
You're gonna kill me, Corey.
It's okay, last question. This one, I promise, last question.
Okay. If there's if outside of the bracket is like 6x, is it still x equals 0?
Yes.
Yeah.
Because the whole 6x equals to 0. Yeah. So in fact, if you've got the end points and then the stationary point, you can actually just kind of sketch it. Alright, so I'll just sketch this one for you guys just to see. So I've got a point 0, 0, 2, negative 8, and 4, 32. So 0, 2, and 4, negative 8, 32. So let's say this is negative 8. This is 32. So we've got the point 0, 0, 2, negative 8, which is like here, and then 4, 32, which is like there. The turning point is 0, 0, and 2, negative 8. So we go from here down to here, and then comes back up. And it has to stop around here. Like that. Does it make sense?
Yeah.
Yeah. So in this case, the local minimum is also the absolute minimum, and then the absolute maximum is actually at the end
Yeah.
of the function.
That was so much fun.
Easy, right?
Yeah.
Okay. Hopefully you guys will remember the majority of this by next week. So yeah, 19 is a really long one. I don't think your school will spend too much time because most of the time is be on here. Students go home, practice the questions yourself. The teachers will go through the examples. I'm sure they will go through the example, but they will probably go through it quite fast. So the challenge for you guys, when you get to this question, to this chapter, try to explain to your friends. If anyone is a bit confused, try to explain to your friends. If you can explain to your friends, it will really help you with your understanding.